Hello and welcome to Aryabhata Ashram. I am M. Maheep and we are doing daily answer writing practice session for mathematics optional. This is very crucial for your preparation, especially for 2026 mains. And I'm going to write a question that is find the orthogonal trajectory of x square plus y square is equal to ax. This is asked in Civil Services Examination 2012. Now, what is so great about this question is the fact that this has also some correlation with fluid dynamics and complex analysis. So, I have a circle. This is a coaxial circle. So, I will be telling you the procedure to solve this. So, mostly students make mistake. I will be telling you those mistakes. So, what they do, everyone, what they do, just differentiate it 2x plus 2y dy by dx is equal to a. Correct? Now, what mistake they do is that they do not eliminate this a and rather they change dy by dx by minus dx by dy and integrate. So you have to eliminate the parameter. आपको ये जो a है इसको remove करना है, यानी इसको substitute करना पड़ेगा x plus y dash से, और किस इक्वेशन में पुट करेंगे? पहले इक्वेशन में पुट करेंगे, फिर आप इसको चेंज करेंगे. तो एक्स स्क्वायर प्लस वाई स्क्वायर इज इक्वल टू ए के बदले एक्स प्लस वाई डैश इंटू एक्स. करेक्ट? तो दिस इज योर 2x स्क्वायर प्लस 2xy dash x square plus y square. Okay, so I can write 2xy dash is equal to y square minus x square. Correct? Now, in orthogonal trajectory, what we do, we change y dash by, we replace y dash by minus of 1 by y dash. So, this is 2xy dx by dy is equal to x square minus y square. Correct? So, I have used this minus sign here. So, this is the case. Now, this is invariably homogeneous equation, but I can also write this as m dx plus n dy form. So, I will write this m dx plus n dy is equal to 0. So, m is equal to 2xy, n is equal to y square minus x square. So, what is del n by del x is minus 2x. What is del m by del y is equal to 2x. Now, they are not exact. So, I need to integrate, have an integrating factor. So, integrating factor I have to find out. So, if I just choose this 1 by m del n by del x minus del m by del y, this is equal to 1 by 2xy, and del n by del x is minus 2x. So, this is your minus 4x. So, this is nothing but minus 2 by y. So, integrating factor, this is complete function of e to the power this. So, this is 2 by y dy 2 ln y. So, y to the power minus 2 is the integrating factor. Correct? I could have done by homogeneous equation also. So, I need to put into this equation 2xy dx plus y square minus x square dy. So, I will be writing it 2xy dx plus y square minus x square dy. So, this is the equation, as you can see, 2xy dx plus y square minus x square dx. So, I will multiply by this integrating factor and this becomes minus x square upon y square dy plus dy is equal to 0. So, if I can, I know this is a perfect differential. So, I can write d This is your x squared. So this can be written as x square by y plus dy is equal to some dc, which is constant. So if I integrate this, so most student I have seen they make mistake in this question. So I'm going to teach you answer verification technique. So this is the orthogonal trajectory. So orthogonal trajectory of a coaxial circle is coaxial circle itself. So the question before me was x square plus y square is equal to ax. So what is the orthogonal trajectory? My answer would be something of this sort. This is x, so this will be a y. Now how it is linked to fluid dynamics, I will be telling you. Now if I ask you what is the orthogonal trajectory of a circle centered at origin, okay, so this is not again coaxial circle, it is a pair of straight line. Then what is orthogonal trajectory of x square minus y square? This is rectangular hyperbola. So all these things are very critical in fluid dynamics. So for this it is xy is equal to k, okay, and for this it is y is equal to kx. So for different parameters it is changing. That is the point you need to take. Now how do I correlate this with complex analysis and fluid dynamics? In fluid dynamics they have given w is equal to tan inverse z, and we have to show that phi and psi are coaxial circles. Coaxial circles. So they are the name of the one and the same. This is asked in IS 2000 and Civil Services 2021. So this is written as phi plus I psi. How do we correlate? That is the matter. Phi minus I psi is equal to tan inverse z bar. Now you find phi and psi, and that you have to show that they are coaxial circle. So this is how we link ordinary differential equation with fluid dynamics, complex analysis, so on and so forth. So if you do like these videos, please share and participate in this answer writing session. Thank you for watching. If you want to join our courses, we are going to launch in July as well. So please visit our center if you wish to, or you can join on online also. You can visit our website aryabhataashram.com. Thank you. इसको देखो पहले.